In this video, we look at how to graph the tangent parent function and its transformations. I first graph tan x using GeoGebra. Type tan x and you get this famous graph. As you can see, it is periodic, repeating itself every period of pi. Here we can see an infinite discontinuity. We can draw the vertical asymptote for it. Just type x equals pi over 2 to get it done. This red vertical line is the asymptote. It is one of them actually, as there are too many infinite number because of the period. You can graph more asymptotes by adding or subtracting multiples of pi. Example, x equals negative pi over 2. Just taking away pi from the previous one. Okay, let's draw one more to the right here. X equals pi over 2 plus the period plus pi. Remember, the domain of tangent x is all real numbers except pi over 2 plus the integer multiples of pi. Here it is. Let us draw one more asymptote here to the left. Yes, x equals negative pi over 2 to the left means minus the period pi, minus pi. This is the general form for the equations of the different asymptotes. Pi over 2 plus k pi, k is integer. At this stage, we have enough information to manually graph this function. We first sketch the famous asymptotes, x equals pi over 2 and x equals negative pi over 2. It's helpful to use these 2 points at pi over 4 and negative pi over 4. The y-coordinate tangent pi over 4 is 1 and tangent negative pi over 4 is negative 1. We get the 2 points, we plot them, and your graph is going to pass through them. Okay, just a smooth graph. Okay. Using the period, you can draw more by repeating it like this. There it is, your graph. Okay, the period is the distance between the two asymptotes, which is pi. Here is a summary of the key facts to remember. In these key facts, we can graph transformations of tangent x. Example, y equals tangent 2x, horizontal compress of scale factor half. A table like this would be helpful. We start with 2x between negative pi over 2 and pi over 2. We include the other values, the main one for seen in tangent x. There are two vertical asymptotes at negative pi over 2 and pi over 2 for 2x. To get them for x, we divide by 2. So negative pi over 4 and pi over 4. Divide also by 2 the other values, the main values. And you get everything set for x. Now we can sketch the graph. Asymptotes first. At pi over 4, x equals pi over 4 is a vertical asymptote. And at negative pi over 4, x equals negative pi over 4 is another vertical asymptote. You use the 2 points at pi over 8 and negative pi over 8, y equals 1 and negative 1. Then join a smooth curve, and here you go, it's done. The period of tangent 2x is the distance between the two asymptotes, which is p equals pi over 2, period of tangent divided by 2. Now let's use GeoGebra to graph this function. So you need to type your function and some equations for the asymptotes you wish to show. Okay, rules to remember: period pi over absolute value of p, and asymptotes x equals pi over 2 absolute value of p plus multiples of the period. Using GeoGebra is helpful to check your manual sketch. Pause this video and manually graph these functions, then check using GeoGebra. Let's do a comparison horizontal shift. Example, y equals tangent 3x minus pi over 3. This is a horizontal compress by a scale factor of 1 over 3, followed by a horizontal shift of pi over 3 to the right. Anyway, using a table would make it easy. So we set the table for 3x minus pi over 3, the values of tangent between negative pi over 2 and pi over 2. This is our tangent function. Okay, so between pi over 2 and negative pi over 2, I set my values on the table. So we get them for 3x by adding pi over 3, because we want to eliminate the minus pi over 3. So we add negative pi over 2 to pi over 3 to get negative pi over 6. Okay, and then we do the same for pi over 2. So we add to get 5 pi over 6. Now we do the same for the other values between negative pi over 2 and pi over 2. The main values are 0, you add pi over 3, you get pi over 3, and pi over 4 and negative pi over 4. These are the main values we have in tangent x. So when we add, we get these values. Okay, 7 pi over 12, and then pi over 12. Finally, we draw a conclusion for tangent 3x minus pi over 3. But before that, we get the values for x. We divide by 3. Everything to be divided by 3, as you can see. Okay, pi over 9, 7 pi over 36 after division by 3, and 5 pi over 18. Okay, now the values, we set the values for the tangent now, which are the same values we have for tangent x, same ones. Okay, so what do we have? At negative pi over 2 and pi over 2, we have asymptotes, vertical asymptotes. So we get these two vertical asymptotes. Okay, and then for the values inside that table, we just put the 0 and the 1 and negative 1. For pi over 4, negative pi over 4 and 0. That's it. Now the table is set to graph. We just draw our axis and we graph the function. We start with pi over 9. So I can set my scale properly here, pi over 9. Now we have negative pi over 18, so we have to divide 9 by 2 to get 18. So I get my scale at pi over 18, which is half pi over 9. Then negative pi over 18. This is the asymptote, vertical asymptote. So I draw my vertical asymptote. Here we are. It's nearly set. Now I need to draw the other vertical asymptote. I go 5 steps, 5 times pi over 18 to get my asymptote at 5 pi over 18. This is the second asymptote. Intersection at pi over 9, because we have 0 there. Okay, tangent 0, and we sketch. We just join and we get the graph. Now this point is the y-intercept. It happens when x equals 0, f of 0. So just substitute in your function by x equals 0. Okay, so you get tangent negative pi over 3. Tangent negative pi over 3 when you substitute x with 0. Approximately you get negative 1.7. Use a calculator to calculate this. Anyway, just for the information, here we are done. We have two vertical asymptotes. That's the main point. Start with the asymptotes and then graph. Done. And using the fact that the function is periodic, you can draw more parts of your graph. Just respect the scale. As you can see here, we have 3 parts. So you respect the 3 parts and you get the intersection. And you get more drawn on the left side than you can do it on the right side. That's it. Now let's use GeoGebra. Type the function to get the graph. Here it is. Your graph just by typing the function. Now for the asymptotes, you should do some work. Okay, start from the asymptotes of the tangent x. Okay, do the reverse of the operation in the function. For x equals pi over 2, add pi over 3, reversing subtract pi over 3. Divide the sum by 3, reversing multiply by 3. And you get your asymptote. Here it is, this asymptote, one of them. Repeat with pi x equals negative pi over 2. So you add pi over 3, divide by 3, and you get your second asymptote. To get more asymptotes graphed, add or subtract multiples of the period to these asymptotes. Okay, which is pi over 3. So multiples of pi over 3. You can add pi over 3 to get one asymptote and subtract pi over 3 from the second equation, second asymptote. Subtract pi over 3, the period, and you get another asymptote. Here it's all done. Finish off, let's look at an example using the degrees as a unit. For example, y equals tangent x plus 30. We dress the table using negative 90 and 90 instead of negative pi over 2 and pi over 2. Then we take away 30 to get the values for x. Okay, so for negative 90, we take away 30, we get negative 120, and we get 60 for 90, 90 minus 30. Then at negative 120 and 60, we have our asymptotes. At 0, x is negative 30, just take away 30. And the tangent for these values is 0 for negative 30, and asymptotes at negative 120 and 60. At 45, negative 45, take away 30, you get your famous values, 15 degrees and negative 75 degrees. The coordinates are y, negative 1 and negative 1. Now we are set. We can graph. We start by drawing the asymptote at 60 degrees. Okay, so this is my asymptote at 60 degrees. Vertical asymptote. And then before we draw the other vertical asymptote, we need to scale our x-axis. I'm going to use steps of 30. So 30, and then the y-axis at 0, and then negative 30, negative 60. I go in steps of 30. And then double negative 60 to get to negative 120, the other asymptote. So this is my second asymptote, x equals negative 120 degrees. So my asymptotes are set. Now I can graph. I just need to plot the x-intercept. Okay, negative 30, 0. So that's the x-intercept. Okay, now I can just sketch my graph. Okay, using the asymptotes and the shape of the tangent graph. That's it. Just join and you get your graph. Okay, I can add to this graph the points with coordinates 15 degrees and 1, and negative 75 degrees and negative 1. So I plot 15 and 1 and negative 75 and negative 1, just to show these coordinates and to scale the y-axis. Here it is, all done. You can use GeoGebra to sketch and check this function. That's it. Thank you for watching and see you soon with more videos, of course.